Welcome to Session 4 of Unit 4 in learning the course Design and Analysis of Algorithms. In our previous session, we seen the applications of backtracking method. Those applications are n-queens problem and sum of subsets problem. In our today's session, we are going to see another application of backtracking, which is nothing but Hamiltonian cycles. The main objectives of this session are to understand Hamiltonian cycles problem, to solve Hamiltonian cycles application by following backtracking algorithm design technique. The learning outcomes of this session are, by listening this session, one can understand Hamiltonian cycles problem statement and able to follow backtracking strategy to develop algorithm for solving Hamiltonian cycles application. The topics that we are going to discuss in this session are Hamiltonian path, Hamiltonian cycle, problem statement, algorithm, and solving an example. Now coming to Hamiltonian path. What is a Hamiltonian path? Hamiltonian path is an undirected graph is a path that visits each vertex exactly once. What is Hamiltonian path? A Hamiltonian path in an undirected graph is a path that visits each vertex exactly once. So that is, here we can say the Hamiltonian path as it starts with a vertex, and ends with a vertex. Hamiltonian path starts with a vertex and ends with a vertex. Now here the path, in its path, it visits some vertices. So the visiting is to be done in such a way that if there is an edge between two adjacent vertices, that is, there should be an edge between these two vertices. There should be an edge between these two vertices. There should be an edge between these two vertices, and there should be an edge between these last two vertices, like that. Now, and V1 is not equal to V2, is not equal to V3, is not equal to so on, not equal to Vn. That is, the vertices are not repeated. So, every vertex should be visited exactly once. Every vertex should be visited exactly once. And visiting process should also be done through the edges. Visiting process should also be done through the edges. And the Hamiltonian path starts with a vertex and ends with a vertex. So finally, how we can define a Hamiltonian path? A Hamiltonian path in an undirected graph is a path that visits each vertex exactly once. Now here you can see the example for Hamiltonian paths. Now here if you take this graph, for this graph I am starting visiting from the vertex A. I can move towards B, and I can move towards C, and I can move towards D, and I can move towards E. That is A to B, B to C, C to D, and D to E I am moving, which started with a vertex, which ends with a vertex, and all the vertices are unique vertices, and visiting process is done through the edges only. So this becomes a Hamiltonian path for the given graph. A Hamiltonian path for the given graph. Now if you observe this one, what is the Hamiltonian path? E to A, A to B, B to C, C to D, D to we can stop the process, or we can continue the process. Since no repetition, we cannot move towards A. That is, we are moving E to A to B, B to C, C to D. This is one Hamiltonian path. We can write more number of Hamiltonian paths for a graph. Suppose for example, if you are going E to A to D, D to C, C to B. This also becomes a Hamiltonian path for this graph. Okay, so starts with a vertex, ends with a vertex, and visiting is done through the edges, and all the vertices are distinct vertices. So we can say that that also a Hamiltonian path. Now if you observe this graph, for this graph there is no Hamiltonian path. That is, if you want to move to this direction, you can move to here, but we cannot visiting D. We are not visiting D. If we are moving in this direction, we can visit F, A, D, C, E, but we are not visiting C. So anyway, if you are moving in any direction, you are missing one vertex without visiting. So that's why this graph is not having any Hamiltonian path. Now let us see, coming to Hamiltonian cycle. What is a Hamiltonian cycle? It is also called as a Hamiltonian circuit. A Hamiltonian cycle is also called as a Hamiltonian circuit. A Hamiltonian circuit is a Hamiltonian path such that there is an edge from the last vertex to first vertex of the Hamiltonian path. There is an edge from last vertex to first vertex of the Hamiltonian path. So, if your Hamiltonian path starts with V1 and ends with Vn, there should be an edge between Vn to V1. There should be an edge between Vn to V1. Now, we can define a Hamiltonian cycle as a path which starts and ends with the same vertex. We can say that a Hamiltonian path which starts and ends with the same vertex is called as a Hamiltonian cycle. So here also it should starts with a vertex and ends with a vertex. The visiting should be done through the edges, and there should be every vertex should be visited exactly once except the starting and ending vertices. Now here, what is a Hamiltonian cycle for the given graph? Here you can observe the Hamiltonian cycle for the given graph. Suppose for example, here we are starting from some vertex. We are starting from some vertex. Suppose if I am starting from this vertex, I am visiting this vertex, and 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 I am visiting this, and this, and this vertex, 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 and this, and this, and this, and this, and this, and we are ending here. If you observe, I visited all the vertices exactly once. Let us see. Here this is, except this one. This is the starting and ending vertex. Starting and ending vertices are same for a cycle, and this is visited once, this is 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 once. Every vertex, I visited every vertex exactly once, and I visited all the vertices. I visited all the vertices in the given graph, and starting vertex and ending vertices are same. So this is a Hamiltonian cycle. This becomes a Hamiltonian cycle. Now, let us see the next one. Problem statement. What is a problem statement here? Given an undirected graph with n vertices, the Hamiltonian cycles problem is to find all Hamiltonian cycles in the given graph. Here, what is Hamiltonian cycles problem? We are given an undirected graph with n vertices. We need to find the Hamiltonian cycles that are present in the graph by following backtracking method. The time complexity of the Hamiltonian cycles problem is big O of n factorial. So in backtracking method, if you solve the Hamiltonian cycles problem, it takes a time complexity of big O of n factorial. Now coming to one more example for Hamiltonian circuit. Let us see here graph A, which shows a Hamiltonian circuit A, B, B to D, D to G, G to E, E to H, H to F, F to C, C to A. That is, every vertex is visited exactly once and starting vertex and ending vertices are same. So that's why it is a Hamiltonian cycle. Now graph B, another Hamiltonian circuit. What is the Hamiltonian circuit in graph B? A to B, B to C, C to E, E to D, D to A. So here starting and ending vertex is A and we visited all the vertices and the visiting is done through the edges only and every vertex is visited exactly once. So this becomes a Hamiltonian cycle. Now what is another Hamiltonian cycle? Can we find another Hamiltonian cycle for this graph? If you observe, if you are moving A to D, D to C, D to E, E to C, C to B, B to A. Now let us observe. We are moving A to D first. We are moving A to D first, D to E, E to C, C to B and B to A. Now the starting vertex and ending vertex is A and I visited all the vertices exactly once. So this becomes another Hamiltonian cycle for the given graph. That is, a graph may contain more than one Hamiltonian cycles. Now the backtracking process finds all the Hamiltonian cycles which are present in the given graph. Now let us see how to construct a state space tree for finding the Hamiltonian cycles in the given graph. Now here let us see, this is the given graph. For this graph, how to find the Hamiltonian cycles. Now initially I am starting with the node A. Initially we are starting with the node A. Now where from node A, where I can reach B, I can reach C and I can reach D. That is, there are the edges from A to B, A to C and A to D. So that's why I written B, C, D. Suppose first I am considering B. From B, where I can move C, I can move E. Now C, E I represented. Now I am considering B. Now from C2, where I can move C2, I can move D, I can move E. Since AB are also there, but since in the path AB are already came, just we are taking only two, D and E. If I am considering D, D to E and D to F I can move. And if I am considering E, from E I can move towards C, D, B, F. Already B, C, D came in the path. So that's why we have only one option which is nothing but F. I can move F. But from F, there is no path to A. Even I already visited B, C, D, E, F exactly once. If there is a path from F to A, then it becomes the Hamiltonian cycle. But here there is no path from F to A. This becomes only Hamiltonian path, not a cycle. It becomes only Hamiltonian path. Starts with a vertex, ends with a vertex. All the vertices are visited exactly once. So this becomes a Hamiltonian path. If there is an edge from F to A, then it becomes Hamiltonian cycle. So in this path, we are not getting Hamiltonian cycle. So we are backtracking the process. In backtracking process, what we are considering? Now let us see. From E, we are considering another way. So which is C. From E we can move F or from C. Here also from C we cannot get the path. We cannot get the process. That is, so that's why we are moving to another one, F, F to D and F to E. Here also I am not getting the path. Now see here we are getting the solution. What is the path is, first we are taking A to B, B to C and C to E, E to F, F to D and D to A, which becomes one of the solutions of the given graph, that is the Hamiltonian cycle. Now What is the algorithm developed using backtracking? Here, for our convenience, we represented algorithm in two parts. The first part is Hamiltonian cycle of k and another part is next value of k. Here, this next value of k is called, that procedure is called in this Hamiltonian cycle. Now, let us see the problem. Next value of k. So, here that next value of k returns either true or false. Now, let us see. If x of k is equal to 0, then return. If k is equal to n, then write x1 to n. So, if x of k is equal to 0 means we are not getting solution in that path. If we are not getting solution in that path, we are returning the process. If k is equal to n, that is we are reaching all the n vertices. In that case, we are writing the solution x1 to n and we are calling the Hamiltonian cycles problem for k plus 1. So, that is with k, if we selected the vertex k, if you are not getting the solution, if we selected the vertex k, if you are not getting the solution, if you get the solution, then you return the solution. If you are not getting the solution, else, if you are not getting solution, in that case, we are calling the Hamiltonian cycle of k plus 1. Now, here what is that one next value of k? Here what the process that we are repeating is x of k is equal to x of k plus 1 mod n plus 1. That is we are selecting one vertex. Randomly we are selecting here mod n plus 1. Why we are taking that mod n plus 1 means we are selecting randomly one vertex out of n vertices. If x of k is equal to 0, then we are returning if g of x of k minus 1 comma x of k not equal to 0. Now, that is not equal to 0 means that is there is an edge between k and k minus 1. Then for j is equal to 1 to k minus 1, if x of j is equal to x of k, then break. That is if both the vertices, the vertex j and the vertex k are equal. So, we cannot visit same vertex twice. So, that's why we are break the process. If j is equal to k, then if k less than n or k is equal to n and not equal to 0, that is g of xn comma x1 not equal to 0, then we are returning the process. That is not equal to 0 means that is there is an edge from starting vertex to ending vertex. So, if there is an edge from starting vertex to ending vertex, then we are returning the process. Okay. So, this gives entire Hamiltonian cycles algorithm which is developed based on backtracking. I hope you all understood the Hamiltonian cycles problem. I'm going to summarize the concepts what we explained in this session. In this session, we explained about what is Hamiltonian path, what is Hamiltonian cycle, and what is problem statement, and then how to solve or how to construct a state space tree for finding the Hamiltonian cycles in the given graph. And also we seen the algorithms developed based on backtracking process. To assess yourself here, I given some questions. Please answer these questions. The first question is, the problem of finding a path in a graph that visits every vertex exactly once is called. Option A, Hamiltonian path problem, Hamiltonian cycles problem. Option C, subset sum problem. Option D, turnpike reconstruction problem. The next question is, which of the following problems is similar to that of a Hamiltonian path problem? Option A, knapsack problem. Option B, closest pair problem. Option C, traveling salesman problem. Option D, assignment problem. The next question is, state Hamiltonian cycles problem. Find the Hamiltonian cycles in the given graph by constructing the state space tree. Here I given a graph with 8 vertices. Construct the state space tree for finding the Hamiltonian cycle which are present in this graph. In preparing this presentation, I used the digital content from various public sources. It is only used for educational purpose and not for the commercial purposes. Thank you for listening the session.